Now let's consider, we've already looked at fixed points. Now let's consider the another kind of points called periodic points. Periodic points. Periodic points are points which are not fixed. It's like a generalization of fixed points. Let me give you an example first. So consider this, iterate, and I say lambda x, 1 by x. This is a function, and consider any number. Take 10 iterations. You can see that this goes between these two, 0.52, 0.52, 0.52, and this is the case with anything. Right? Anything except, of course, 1, which is fixed, and minus 1, which is also fixed. So 1 and minus 1 are fixed. Any other thing, any other point between minus and plus infinity, except 0, of course, is a periodic point. It alternates between 2 points. The orbit alternates between 2 values. So a periodic point, P, is a periodic point if f of n of P equal to f of P, right? For some value of n. So the idea is that if you iterate, you will come back to that value again, right? And it goes on like this repeatedly. Now, the smallest value of n is called the prime period. So the smallest value of n is called the prime period. So if for example, if you say f of n e of p will be the same, if assuming this is equal to f of p, then it makes sense to say, f of 2n of p will be equal to this, and so on and so forth for all values of this. So 2n, 3n, 4n, 5n, anything. So you can say f of 3n of p, this, etc., and it goes on like this. So we don't want all of these. We just take the smallest of this and say that's what we call the prime period, f of n. Right? This is a periodic point. Now, there are some things which are not fixed and not periodic, but they are eventually fixed or periodic. Right? This is another kind of point. All right. Now, how do we do this? Eventually fixed and periodic points are points which are not fixed or periodic, but after a while they reach a fixed or periodic point. It's easier to explain this with an example. If I take lambda x, right, iterate lambda x squared, right, and we know that 1 is a fixed point for this. What about minus 1? Minus 1 is not a fixed point itself, but it becomes a fixed point. Right? After one iteration, you apply the function f of minus 1 becomes 1, and then it becomes fixed. So this is actually a fixed point, but it's an eventually fixed point. It's not a fixed point itself, but after iterating for 1 or more times, it becomes a fixed point. Right? So a point is an eventually fixed point if f of n of p equals p, equals some value q, where q is a fixed point, right? For some similarly for periodic points. So after a while they become fixed, they become periodic. So another example would be if I were to say sine of just say sine and say of pi, that would become 0 after a while. This is the same, and this would be the same for 2 pi, 3 pi, etc. So these are all very, very small numbers. It's just rounding errors because of which it doesn't look like 0, but for practical purpose it is. There are also what are called eventually periodic points, which are not themselves periodic, but after a while, you iterate 1 or more times, then they become periodic. And as an example of this, let's take the function, let's check, X lambda iterate x lambda, and let's take lambda of x raised to 4 minus 1, and the number we are interested in is 1, right? And let's iterate 10 times. This 1 itself is not on this period, right? But if you iterate once, it becomes 0, right? And after that, you get a periodic thing between 0 and 1, 0 and 1, 0 and 1, 0 and 1, etc. So this is eventually periodic function. So I can say and point is an eventually periodic point if f of p, if after some number of iterations it hits a periodic point and it stays that way. I'm not trying to write it down. So that's a periodic, eventually periodic point. All right. So let's put some examples over here so that let's just say f of x equals 1 by x. All points other than 1, minus 1, and 0 are eventually fixed. And another example, let's take it, sine of x, all points, let's just say 2 pi, 3 pi, pi, are all eventually fixed. Now, eventually periodic, if you say f of x equals x raised to 4 minus 1, and 1 is an even. So we have fixed points which don't vary, periodic points that cycle between a number of these things, and eventually fixed and eventually periodic points. Right? So now that ends this segment. We'll talk about how we can visualize this so that we can see it a little better.